Hello everyone, my name is Chu Kong. Today I'm going to present our tool named Evently for modeling and analyzing Reshare cascades with Hawkes processes. Hawkes processes are known as the self-exciting processes that are used for modeling the self-excitation phenomenon. The self-excitation means the occurrence of new events will increase the likelihood of future event happening. Such phenomenon is observed and previously studied in many diverse fields. For example, Hawkes processes have been applied to model earthquake aftershocks. Where there is an earthquake, it is likely to trigger some follow-up aftershocks. In finance, stock buying events may also attract future buying orders from others. Also, in neuroscience, where neurons are naturally exciting each other. Another field that we are particularly interested in is applying Hawkes processes to model online information diffusions. In online social media platforms such as Twitter, the online information diffusions are usually studied in the form of Reshare cascades. As shown in this example, the self-excitation comes from the event resharing among users. For example, in this network of Twitter users, this user posted an initial tweet and his friends saw it and chose to retweet, which further exposed the tweet to more users. Eventually, this creates a Reshare cascade. Now that we have observed the self-excitation phenomenon in real data, let's take a look at the definition of Hawkes processes. Here we list the intensity function of Hawkes process, where we can see that the event intensity is determined by two components. First is the background intensity ST, which defines the likelihood of background event happening. The second component is a sum over the contribution of all previously happened events. The contribution of previous events are following a decay function phi, where the decay kernel decides how quickly the influence from previous events will diminish. We can see from the example figure on the left-hand side, the purple event is a first event coming from the background. Its likelihood of triggering future events follows this decay function as shown in this color. And in total, it spawned two events in red and green. In the end, those two events also excited their own child events as shown in those dots. There are several existing tools that implement the Hawkes processes. Those packages usually have different emphasis. For example, TIC is a widely used package for modeling time-dependent processes in general. The Puppy package, on the other hand, is a point process toolbox based on PyTorch. Many other tools are usually provided as scripts with limited feature. Therefore, we developed Evently, which is featured in several aspects. We just learned about the preliminary of self-exciting processes. In the following part of this video, we're going to introduce Evently with three highlights, and then present a tutorial on online diffusion modeling to demonstrate Evently. First, Evently is a toolbox dedicated for modeling self-exciting processes. It is implemented in native R language with limited dependencies to fit and simulate around 20 variants of Hawkes processes. Those include different kernel functions, such as exponential and power law functions, different exogenous functions, marked and unmarked Hawkes processes, the finite population variants, and the joint fitting variant. Second, Evently uses the state-of-the-art nonlinear optimizer for learning parameters. This is important due to the complex objective functions of learning Hawkes processes. Usually, it is a constraint optimization problem where the parameters are usually bounded. For this reason, we employ AMPLE for solving the problem. It allows for efficiently defining optimization problems and connecting the optimization to a wide range of global and local solvers. Last, Evently is designed with an emphasis on online information diffusion modeling. This includes some dedicated data processing tools for Twitter data, and some popularity measures for online information diffusions. And Evently also provides some recent developments in generating feature vectors for characterizing online users and online content. Those diffusion embeddings can be used together with off-the-shelf machine learning tools. Then we're going to present a short tutorial on online diffusion modeling. Let me walk you through the tutorial. We apply the online social media data specifically we are going to use the toy dataset collected by Chen et al. Since January 2020 on Twitter discussions about COVID-19. Due to the large volume of this discussion on Twitter, we only use 1 day worth of the dataset. In the dataset, we select 2 example Twitter users, with one of them is a fan of a Filipino author, and the other one is a Korean pop star. Later on, we are going to characterize those 2 users. We can actually see how their influence on Twitter are. To get started, the installation of Evently is simply via a single line of code as shown here. To set up Evently with Ample and other solvers, it usually involves solving various library dependencies and compilation. In this package, we made it easier by introducing an automated installation process. On your first load of the package, it detects those tools and asks for setting up. If it fails to find the tools, it'll set up everything in a few minutes. Then we follow this pipeline of working with Evently, where our first step would be processing the raw data collected from Twitter API. The data from Twitter API is usually in JSON formats, such as this example on the left-hand side, where there are fields like Twitter time and Twitter IDs. To process such data, Evently provides a dedicated processing function. Calling this function will collect all relevant information from the data and put them in a format that is compatible with Evently. Then we move to the phase of cascade modeling. Evently implements a unified API for fitting Reshare cascades with different variants of Hawks processes. With this fit series function, you can choose different models for fitting Reshare cascades by specifying this model type argument. In this example, we fit the cascades with 2 different models, a marked Hawks process with parallel decay function and a seismic model from prior work. Eventually, let's take a look at what kind of applications or analysis we can do with event. We can first use the fitted model as a generative model and simulate new Reshare cascades and see how the cascade can unfold. In this example, we simulated a possible Reshare cascade from the fan of the Filipino author account, and you can see this is the Reshare cascade may look like from here. We can also inspect the fitting model for different Reshare cascades. In this plot, we show the kernel functions of Reshare cascades fitted from those both users we mentioned earlier. To note that the kernel functions are a component of Hawks processes which encodes the influence from an individual event to future event generation. We can see that this Korean pop star actually has longer standing influence to event diffusion than this fan account. Evently can also generate many popularity measures that can be used for analyzing a user or an online content. We show here several known measures described in literature. The final popularity predicts for Reshare cascades the total retweets they might attract in the end. Here, in the first 2 lines, we show the predicted final popularity for 2 different models. And actually, the first model predicts the popularity more closer to the actual popularity, which is 458 events for the cascade. The branching factor here is a measure indicates how many retweets are likely to be attracted for a single tweet. The viral score then measures the expected size of a cascade posted by the user. Lastly, based on the Reshare cascades initiated by different users, Evently can generate feature vectors which we dump as diffusion embeddings for each user. Such diffusion embedding characterize for each user their diffusion patterns. We can then run a standard dimensional reduction technique called TSNE and then cluster the users in the latent space. To understand the cluster, we visualize the users in this latent space and also highlight them with another tool called Bird Spotter, which provides the bot-like scores for users. And we can see that the bots and the non-bots are separated well by the diffusion embedding. By the way, Bird Spotter is also going to be presented in the demo track this year at Wisdom. Please check out its demo presentation if you are interested. In summary, in this short video, we present a self-exciting process toolbox, which is designed in native R language with limited dependencies. And It uses the state-of-the-art nonlinear optimizer for learning parameters, and it is also designed with an emphasis on online information diffusion modeling. And please check out the demo here on GitHub. And I also acknowledge the support of SIG IR travel grants, which enabled me to attend this conference.